Homework busy? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
Question 34 states that tritium is a rare isotope of hydrogen that can be produced by the following fusion reaction. Two unknowns fuse to form tritium and a gamma ray. Part A of the question asks to determine the atomic mass number A and the atomic number Z and the names X and Y of the unknown particles, and using the masses given in the reaction, determine how much energy is released by this reaction. Okay, so part A, basically figure out the unknowns. So to do this, we can balance out our terms on the top and terms on the bottom of a reaction so they're equal about our reaction sign. So if we do it for our atomic masses, we have 1 plus A equals 3, which means, of course, A here would have to equal 2. And same for Z. Z plus 1 has to equal 1. Therefore, Z has to equal 0. And so we can determine, based on the values now that we have, that our first term, maybe I'll do it this way, first term is 1, 0, which has to mean it's a neutron. And our second term here, with our arrow there, we have 1, which means it has to be either a proton or hydrogen. A is 2, so now let's do deuterium, so this is H. So these are our two unknown terms, which we can solve for, which is what is asked of us in part A. And part B, using the masses given, determine the change in energy. So we know that an energy released in this type of reaction is given by the absolute value of the change in masses of the reaction multiplied by c squared. This change in masses, I'll represent it as their final mass minus our initial about the reaction sign multiplied by c squared. And so if I type this out, this equals absolute value of our final terms, which is just tritium, in this case. So with the mass given to us in the question, minus our initial terms, so that's deuterium and a neutron. All has units of U, lowercase u, multiplied by our conversion to get MeV out of the mass. So it's 931.5 MeV per U per c squared, and multiply that by c squared. And we'd find, by plugging this in, we would find the energy released in this reaction is 6.2 MeV. There you go.